All right, ladies and gentlemen, the next question gives us this rational function. Remember, it's called a rational function because it's the ratio of two polynomial functions, and of course the one in the denominator includes a variable, which means there's going to be a restriction involved. You want to make sure that the denominator never becomes 0. But anyhow, we're given this function, and the first question is the function a one-to-one function? Well, I think if you take your calculator and you plug it in, let's see what we get. Let me turn it on. Y equals, I'm going to clear out what I have. I'm going to type in the numerator, which in parens, in parens is going to be 9x plus 5, close it, divided by, in parens, 3x plus 2, close it, and graph it. Wow, we come out with a very weird looking, very weird looking picture. If I zoom in, let me hit zoom in. I get a little bit better idea what's happening, but the most important thing that you've got to catch, and it's kind of weird to tell on a calculator, but what's actually happening here on the calculator is you have a vertical asymptote that's going to occur where the denominator is. So that line is not actually a part of the graph itself. So to be completely honest, this function, let me go back to just where we were, go back to a standard window. This function is going to pass the both the horizontal and the vertical line test. Now, me personally, at the level of college algebra, all right, you're not in pre-calc yet. At the level of college algebra, I would start off by saying this is a one-to-one function, because it is. But it's kind of hard to tell it on the calculator. You just saw, okay? But this is a one-to-one function, so that means we can find its inverse formula. So let's do that. Let's start off. Y equals 9x plus 5 divided by 3x plus 2 is my original function. That's the original. When I find the inverse, I write x equals 9y plus 5 divided by 3y plus 2. That's my inverse function. Okay? So all I did is I changed y to x, and each of these x's became y's. Alright, this x is really x over 1. We want to solve this equation for y, so I'm going to cross multiply. X times this quantity results in 3xy plus 2x, and that's equal to 1 times this, which is 9y plus 5. We're solving for y, so we want to change location. I'm going to get all my y terms on the left, so I'm going to leave the 3xy where it is. The 9y is going to end up over here as a negative 9y. The 2x is going to end up over here as a negative 2x, and the 5 never moves, so it stays with the same sign. What I'm now going to do is factor out a y. In parens, that leaves me with 3x minus 9, and that's equal to the opposite of 2x plus 5. And to finish, I'm going to divide by this, so I have the opposite of 2x plus 5 divided by 3x minus 9. And that is my inverse formula. So F inverse is equal to the opposite of 2x plus 5 divided by 3x minus 9. So that is my formula for F inverse. The only part to this problem that I find weird in 1105, to decide if the function is one-to-one, looking at a picture of that really takes some readjusting of that picture to understand that it does pass the horizontal, the vertical and the horizontal line test. But trusting that it is one-to-one, which it is, you do get its inverse function. Now, the last question asks me what the range of f of x is. Now, this is f of x, and it's easy to find the domain of f of x by just throwing out whatever the restrictions are. But finding the range of f of x is kind of difficult by looking at a graph. I mean, people, look at that mess that we just had there. Trying to find the range would not be easy. So let me give you a quicker way to do it. Here's what I want you to remember. You know how inverse functions relate to each other. The range of the original function, the range of the original function would be the domain of the inverse. They switch places. So if I want to find the range of f of x, I'm really looking for the domain of f inverse. Well, hopefully that's very easy to see. This is f inverse. Hopefully you can tell the domain is every real number except 3, because if I put in a 3 it would make this become 0. So the domain of the inverse function is all reals except 3. That would also be the range of the original function. The domain of the inverse is the range of the original. So it would be all real numbers except 3, and I would write that as negative infinity to 3 union 3 to infinity. All real numbers except 3. So I hop around the number 3. All right, so a lot of stuff going on here, people. A lot of stuff that you need to spend some time practicing. Remember, inverses are new to a lot of you, so it takes looking at them, studying them, watching the video, doing the homework. Don't give up on this stuff. It takes time to catch it. It just doesn't. For some people, it goes real fast. For others, it takes repetitive studying. So don't be afraid to study. You need to in this material.